What we're going to do is construct new power series from simple power series like geometric series or something like that. So I'll show you how to do some basic problems. There aren't any X-rated ones this week, so we'll have a look at just the basic idea. So. Okay, remember, if you can't see, you can turn one of those lights off. You're not going to be bothering me if you do that. All right, so this is part A. X plus 1 e to the x. So our function g is defined in the following way. How can we build a power series, I guess, for g of x about x equals 0? Any ideas? I guess. Well, I guess Cn's a sequence, whereas e to the x is a function. There's no n in e to the x, but I guess as a first a first thought, what is the power series for e to the x about x equals 0? The Maclaurin series, right? We know that. So the Maclaurin series, which you should know straight off, is just this. So it involves powers and factorials, right? Now, I've made a bit of a claim here that this function and this series are equal, right? But for what x values do we actually have equality here? For what x values does this series converge to this function? Anyone know? Huh? Well, all values of x, right? Okay. So you can verify that by using ratio test. Okay, so to get the series for g of x, from this, let's just multiply the series by x plus 1 in brackets, right? It seems logical. Now, this guy here's got nothing to do with k, so we can move him into the sum if we want. And there's our series for g of x. So we didn't have to compute anything really. It's just building a new series out of a known series. So it's pretty straightforward. Let's move on to C. Here we have our function g of x defined in the following way. And we're asked to come up with a power series for this function, g of x. Now, I think we're given a hint in this one. We are using a power series. This is a special power series known as the geometric series, right? Now the first question is, if we're going to use this series, this special series, what x values is this series valid for? Down here. One's definitely out because that's not defined. Right. So it's not. You have to be careful with these series. So here. Now you can come up with this interval either via the ratio test or just looking at the partial sums of this series here. Okay. It's back in, I think, grade 10, grade 11. Now, the point is that if we're going to do calculations with this special series, we're always restricting ourselves to this interval, okay? So that's important. If we're going to work with something, we need to make sure that all the calculations we do with it are well defined. So to ensure that happens, we're restricting our x values to this interval. All right, so any ideas how we can form the series for G from this boxed series? Differentiate, right. So let's call this, yep, you guessed it, star. So on the left-hand side, we're going to get something like 1 minus x all squared. Now that's equivalent to G, right? So all we really have to do is to go through here and differentiate term by term. Now, sometimes with these, I like to actually write out the first few terms of the series and then just differentiate and then collapse it back into a series. With this one, I'm not going to do that, okay? So I'm just going to differentiate. So the first term's going to go to 0, and I'll get something like this. Okay. Now, what values of x do we have this equality for? Okay, what values of x? Well, right, between -1 and 1, right? So again, pretty simple. All we did was use the geometric series, which is something you saw at school, to get another result. Has anyone seen anything like that method before? Okay, all right. If you haven't seen it, that's okay.